I'm going to show you here two examples of how we can use trigonometry to find a missing length in a triangle. The first thing I'm going to draw your attention to is at the top I've written out the three trig functions that we're going to be using, either sine, cosine or tangent, and the equations for those. So the fact that sine is equal to the opposite divided by the hypotenuse, cos is equal to the adjacent divided by the hypotenuse, and tangent is equal to opposite divided by the adjacent. And underneath I've just written out something called SOHCAHTOA, which is a useful way that might help us remember these trig equations. So sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite and adjacent. And we'll come and use that in what we're going to do when we're looking at the examples. So the first example is this triangle here. We've been given an angle, a length, and we're looking at finding this missing length here, x. Now what is important when we use trigonometry to find a missing either angle or side is that we've been given two pieces of information in this right angle triangle. I hadn't marked this in before, but obviously we are assuming that that is a right angle there, and that allows us to use trigonometry here to find that missing length. The first thing I'm going to do is label the sides of this triangle. So we need to remember that the hypotenuse is going to be the longest length in our right angle triangle, and it's going to be opposite the right angle. The opposite is going to be opposite the other angle we are given, so this will be our opposite, and our adjacent will therefore then be the other remaining length. Now once we've done that, we need to decide whether we are going to be using sine, cosine or tangent to be able to find out the missing length here. And to do so, we're going to need to look carefully at the lengths that we're given. So this is the only length we're given, and x is the length we're trying to find, which tells us we want to use a trig function that is going to include a, the adjacent, and o, the opposite, in that equation. And a and o we can see here come in this one here. So TOA, which tells us it is going to be our tangent equation that involves the opposite and the adjacent. So the first thing I'm going to write out here is that tan is equal to the opposite divided by the adjacent. First thing, because that's the equation we're going to be needing to use to work out the missing length here in this example. The next thing I'm going to do is I'm going to put in all of the information here that we have been given. Okay, so we've obviously got the angle, we've got the length, and we've got our missing length here as well. Now I've written just tan here, but actually this will be tan of the angle we are given here. So in this equation there, I could have written tan theta, where theta represents this angle we're given there. Okay, so I'm going to put all the information we've got here into this equation. So firstly, we've got tan theta. Theta here, in this case, the angle is 20 degrees. 20 degrees. Now I'm putting that in brackets, and I calculate it'll automatically open up a bracket when we put tan in there. That's to make sure that we're only finding tan of that angle and nothing else. So tan of 20 degrees is equal to the opposite. Now the opposite length here we can see is x. We don't know what that is going to be yet. And that's divided by the adjacent, which is 10.5. So putting all the information, that's what we've got at the moment. And we're trying to find out what x is going to be. Now to find out what x is going to be, we need to get x on its own. So what I'm going to do here is I'm going to multiply both sides of this equation here by 10.5. And if I multiply both sides by 10.5, that will get x as the subject of this equation. We'll get x on its own. So multiplying this side by 10.5 will give us 10.5 lots of tan of 20 degrees, and that will be equal to x. We can simply put that into our calculator to find out that value of x. So 10.5 lots of tan, you see the brackets there have opened up, 20 degrees, close bracket, equals, and we get here a value of x as 3.82 to three significant figures, and that is in centimetres because we found a missing length. Now whenever we do this, it's really worth looking back at the triangle and making sure that that is a sensible measurement. We can see here that because this angle is only 20 degrees, we're expecting this length here to be significantly smaller than this length here, and we can see that 3.82 is significantly smaller than 10.5. Okay, if that wasn't going to work out or tie up, then we know that we might have made a mistake in our working somewhere within that. All right, so that's our first example. I'm going to show you now another question and a second example that we're going to look at, and that's going to be for this one here. So we're going to follow a very similar process. We're going to label the triangle. We're going to think about the trig function and trig equation we're going to use, and I'm going to show you how we're going to use that to find out that missing length. So firstly, let's label our triangle. So we're going to go for the hypotenuse is, remember, our longest length. It's the one opposite the right angle. Our opposite is opposite the other angle we are given, and our adjacent is the other remaining length. So we need to decide which one we're going to use, which trig function this time. So we want it to include 12.4 because that's the length we're given. We also want it to include the length that we're trying to find here, which is the hypotenuse. So we want it to involve A, the adjacent, and H, the hypotenuse. A and H here are involved, if we can just see at the top, within K. So this one here, cosine, is equal to the adjacent divided by the hypotenuse is what I'm going to write down. So firstly, cosine of theta, which is the angle in here, we'll come to in a second, is equal to the adjacent divided by the hypotenuse. So that's what we're going to need to use here to find out our missing length. Now we're going to put all the information in that we're given. So here we're finding the cosine of 35 degrees. That's equal to the adjacent, which is 12.4, and that's divided by the hypotenuse, which is x. Now at the moment, if we just compare that to the equation that we had above, they're very similar, but one of the key differences is that our unknown x that we're trying to find here is actually the denominator of the fraction, whereas here it was the numerator of the fraction. It was a little bit easier here to be able to find x because we could simply times by 10.5 to get x as the subject. Here we need to consider how we would then rearrange this to be able to work out our value of x. Now if ever your unknown is the denominator, the first thing that I would do is times by that value, by that variable, so that it is no longer the denominator of that fraction. So the first thing we're going to do here is times by x. If I times both sides by x here, that will give us x lots of cos of 35 degrees, which is equal to 12.4. Now this is x multiplied by cos 35 degrees. So actually this is what we want to get rid of so that we've got x on its own. And because they're being multiplied together, we can divide by cos of 35 degrees. And we can do that to both sides to get x as the subject. So that will give us x is equal to 12.4 divided by cos of 35 degrees. And we can write that like so. The final step then is to put into our calculator what we've got there. So as a fraction, we can write 12.4 divided by cos of 35 degrees, giving us an answer of x, a value of x of 15.1, again to three significant figures, remembering that this is centimetres and this is the length that we've found. If we look back to our triangle, we know that the hypotenuse is always the longest length in a right angle triangle, and 15.1 is longer than 12.4. So the value that we've got is realistic and it makes sense and ties up with the other values that we are given. Okay, and that's a really good check to do once we've found out that missing length, just to make sure that that's correct.